So today I'll talk about detecting and responding to on-chain attacks. Now, if we're looking at the state of the ecosystem, I think we're all aware that it is not in a great state. In 2020, there were about $2 billion in losses, and in 2021, despite kind of the bear market and the bear market, the losses, and not being the end of the year, the losses almost at $2 billion already. So this slide looks at a couple of examples of hacks that happened over the last few months. So Inverse Finance, Badger DAO, and Ronin Bridge. And what I want to relay on this slide and kind of debunk is that attacks that are happening on-chain are not atomic. There is usually some time that is possible to respond to an attack. So Inverse Finance, that was a fairly quick attack. It was a flash loan assisted price manipulation attack that happened in about 8 minutes. Badger DAO, this was an ice phishing attack where their dApp front end was compromised, tricking users into signing token approvals. That attack happened over a 2-week period. And then all of you, I'm sure, are aware of the Ronin Bridge attack. This is where kind of the validator keys were compromised. So it was fairly instantaneous, but I think if you look at kind of the on-chain transactions, but what was unique about this attack was that it wasn't uncovered for 6 days. And this attack also, the US government tied to the Lazarus Group, which is associated with North Korea. So that kind of gives you a sense of kind of the type of adversaries that we're dealing with. Now, the way we look at security is looking at it comprehensively. So there is steps that protocols are already doing in the pre-deployment phase, like utilizing template contracts like the Open Zeppelin library, and then of course going through smart contract audits, and that is absolutely necessary. But it doesn't stop there. You also need to think about the steps during post-deployment. So think about bug bounties, real-time monitoring and alerting, and incident and emergency response. And that the real-time monitoring and alerting is really where FORTA comes in. So FORTA, the way you can think about FORTA, it's a decentralized network. And it's essentially a security camera and alarm system for Web3. It, at a high level, consists of a network of scan nodes. And currently, there is about 10,000 nodes that are deployed on the FORTA network. These scan nodes, to think about them, they're essentially full nodes, let's say Ethereum mainnet node, that then runs community developed detection bots, and I'll talk about the detection bots here in a second, and forwards all the blocks and the transactions to those detection bots. And the detection bots are essentially a script. So think of it pieces of logic or a machine learning model that are developed by anybody that can be deployed onto the FORTA network. So these detection bots really tell the network what to watch out for. And then if kind of the conditions are met, then these detection bots will raise an alert that you're able to subscribe to and analyze. The FORTA network is a separate network. As I mentioned, there is about 10,000 nodes deployed on the network today that monitor 7 EVM compatible chains. So Ethereum mainnet, Polygon, BSC, Avalanche, Optimism, Phantom, and Arbitrum. The FORTA Explorer is essentially a version, think of it as Etherscan for the FORTA network, that allows you to explore the FORTA network. So you're able to look at the scan nodes that are making up the network. You're able to look at the bots that are deployed on the network, and you're able to explore the alerts that are raised by these detection bots. And with each of the alert, you get a whole bunch of additional metadata, like a pointer to the transaction, the block, as well as all the addresses, for instance, that were involved in the particular transaction. Now, I alluded already to this in the first slide, is that attacks are really not atomic. And by analyzing attacks that happened over the last few months, most of them follow these 4 attack stages. So the first stage is really funding. So the attacker needs to have some funds in order to execute the attack. And usually that happens, through privacy protocols like Tornado Cash, but it could also be from exchange, from a other malicious account, through a bridge, etc. Once they have the funds, they often need to prepare the attack. So if we're thinking about, let's say, a reentrancy attack, well, there needs to be a smart contract, an attacker smart contract that needs to be deployed. Once the attack is prepared, they actually move to the exploitation, where they are essentially draining the digital assets from the protocol that is getting attacked. Again, a variety of attack techniques that can be deployed there, from flash knowns to ice phishing, and then various exploits. And then once the digital assets have been obtained, attacker quickly moves into the money laundering stage. They exchange ERC 20 tokens into native assets, and then usually route them again through privacy protocols like Tornado Cash. And so if you think about kind of these 4 stages, now every stage is essentially an opportunity to detect the attacker behavior. And obviously, we want to be able to detect this before any digital assets are being drained from the protocol. So we want to have a high confidence detection in the preparation stage. But even at the end of this particular attack chain, the detection is valuable. So if you think about the Ronin bridge, where the attack wasn't uncovered for 6 days, FORDA would have helped to identify this attack with high confidence, and that would have mitigated further risks to the users of the Ronin bridge. Because in that 6-day period, what happened was that users still happily deposited funds into the bridge that was essentially controlled by an adversary. So let me go through a few examples around detection bots that are deployed on the FORDA network today. So you're able to get a sense of kind of the capabilities that these bots have. Bots, of course, work with the transaction data that is forwarded by the scan node, or the block data that is forwarded by the scan node. But a bot is essentially JavaScript or Python code, and it's able to do a lot. It's able to maintain state over multiple transactions. It's able to reach out to external data sources like Etherscan. Maybe there's some information that it needs to obtain. It's able to run machine learning models. It's able to run essentially arbitrary code. And so that makes it very powerful in terms of kind of the type of algorithms that you're able to develop to identify these attacker behaviors. So Flash Loan is an example bot. So Flash Loan, just for background, it's really a temporary loan that needs to be paid back in the same transaction. It's usually used for arbitrage. But flash loans can also be utilized in kind of economic attacks where the attacker manipulates prices temporarily. And that could lead to an exploit of a vulnerable protocol if they're relying on a price feed that an attacker essentially is able to manipulate. So for instance, they could take out an under-collateralized loan. And so the way that is getting detected in a FORDA bot is every transaction is assessed on whether a flash loan is obtained. So there's a set of protocol addresses that are being assessed. And then kind of the second condition of this particular bot, and this condition really exists to weed out noise of kind of legitimate flash loan usage, is by thresholding the profit that was obtained as part of that particular transaction. The next one is rug pulls. So rug pulls are tokens that are hyped by the creators. They're then traded on decentralized exchanges, and the creators may dump all their tokens, essentially leading to a price crash, and then all the holders of the token are left holding the bag of these worthless tokens. And so there is a detection bot, a rug pull detection bot deployed on the Forda network that essentially obtains the price information from many decentralized exchanges, utilizing kind of the common ABI structure that is used by many different exchanges. And then it triggers on significant price drops. Now, significant price drops is a little bit of a loaded term, because obviously there's a lot of volatility in the ecosystem. And so you cannot kind of hard code a threshold. Let's say if the price drops 50%, that would lead to a whole bunch of noise of this detection bot. And so instead, what we're utilizing here is a time series anomaly detection approach that takes into account historical information. And that means really the seasonality, if there is any seasonality, as well as the volatility of the price over time. And so the chart on the bottom here is essentially kind of price feed. And the little band around it is the prediction of the model on where it expects the price to be. And what happens is, as soon as the price breaks out, then an alert is raised, and that significantly reduces the noise of that particular bot. The next one is exploit simulation. So this is a really exciting bot that was deployed a few weeks ago. So let me explain to you what this one is. So this one takes into account that attackers for many types of attacks need to deploy a smart contract. And there's already a whole bunch of bots that are in place that kind of identify kind of suspicious smart contracts, like, hey, was it created by somebody who was funded by Tornado Cash? Is it verified on Etherscan? Things like that. But these tend to be still fairly noisy. But if you look at the code, all the code is there to execute the attack. And so what the Forda bot does, it monitors all contract deployments. And then once a contract is deployed, it actually locally forks the chain using a Nash. And then it invokes all the exposed functions of the smart contract. So essentially, it does some light fuzzing. Just a shout out, if anybody is working in the fuzzing space, I think we need a better black box fuzzer that can operate on bytecode alone and doesn't rely on source code. Because in this particular instance, of course, the source code is not available. And then as these functions are getting invoked, the bot assesses whether large amounts of tokens are transferred into the attacker's wallet or the contract. And what that bot allows us to do is really raise a high confidence alert before the attacker exploit transaction is mined on chain. So that gives another kind of time advantage for an early detection. Now, one thing that you may say, well, looking at the flash loan example, I see some questions. Hang on. Okay. Sorry, I was just seeing the chat here. So one thing that you may say, well, flash loans, that is happening all the time as part of arbitrage. Wouldn't that lead to an extremely noisy bot? And noisy bots, of course, are problematic in that it leads to alert fatigue on kind of the incident responder side, right? If you get 100 alerts, they all turn out to be false positives, you start paying attention less and less to these alerts. And also low precision makes it difficult to hook up automated incident response processes like pausing a protocol, for instance. So the bots, the individual bots may be noisy. But what you're able to do is to combine bots along the attack stages that I talked about earlier. And what that allows you to do is really reduce the noise, because now you're seeing essentially indicators across this attack chain that are consistent with the attacker behavior of funding, preparation, exploitation, and money laundering. And if we look at the inverse finance attack that I mentioned earlier as an example, what you see on this particular slide is all the bots that fired on that particular attack. So first, tornado cash funding of the EOA was identified, then a contract was deployed. The exploit simulation actually identified that an exploit is about to occur. And at that point in time, our combiner bot raised an alert. But if you can continue to go to the right of the attack chain, there are additional indicators like the flash loan bot fired. The attacker also used flash bots to bypass the mempool, which is another kind of indicator. And then lastly, they moved into the money laundering stage using tornado cash. And so then a second alert, high confidence alert, is fired by the bot. So hopefully that kind of gives you an idea in terms of kind of how the network is structured, the bot capabilities, and then the strategies on how to filter out noise. Now, if you're a protocol and or a smart contract auditor and you want to include monitoring as part of a comprehensive security strategy, there's kind of two approaches you can take here. First is threat modeling. Threat modeling is a technique that's been used kind of in the Web 2 space for many years. And it's really kind of a systematic, thorough approach of decomposing your application and then creating data flow diagrams and assessing risk in a systematic manner. It's very thorough, but quite time consuming. You could also utilize checklists based on your individual expertise and your knowledge of past attacks. But independent of what approach you're taking here, you're really about identifying risk. And then once you identify the risk, and I'm sure this is happening in kind of smart contract audits every day, there is a few paths you can take. You can accept the risk. You can eliminate it either through changes in the design or code changes, or you can reduce the risk through on-chain monitoring after deployment. So once you identified the risk, you prioritize the risk, you know which ones are eliminated, which ones remain that you now want to monitor more closely. And there is a variety of paths that you can take. So first of all, the first path is to utilize the already deployed detection bots on the Forta network. These are essentially generic detection bots that identify these generic attack behaviors that I mentioned earlier. They're customized for the type of protocol that you're dealing with. So there's a DeFi kit, there's an NFT kit, stablecoin, bridge, and governance. And so they all kind of have different types of bots that look at attack behavior that pertains to that type of protocol. And these bots are already deployed. They're bundled in these kits, and all you need to do is subscribe to them through the Forta app. You specify your contract addresses as part of the subscription, and then you start receiving alerts. Now, these threat detection kits kind of cover the generic attacker behavior, but there may be a protocol-specific risk that you identified through your analysis. And again, there is a lot of resources that you can leverage that are already deployed on the Forta network. So there's hundreds of bots on the network, and through the Forta app, so the Forta Explorer that I mentioned earlier, you can search for them. So if we're thinking about kind of flash loans and Oracle price manipulation, you can search for Oracle, and that will give you all the bots that may be a fitting kind of starting point to monitor the particular risk that you identify. Or you can look at the top protocols that utilize Forta today. If you go to the Discover page on the Forta app, you see the screen here on the right. So if you, for instance, have a lending protocol, you could take a look at what bots Aave has deployed, and they may be suitable for the risks that exist in your lending protocol as well. And then lastly, if there are some risks that existing bots don't allow you to monitor, you can develop a bot yourself. And bot development is very straightforward. It's permissionless, so anybody can develop a bot and deploy it onto the network. And deployment happens within minutes, and you'll start receiving alerts. And so for custom bot development, you need to define the requirements, like what is the logic of the bot, what alerts will the bot emit, what data do you need? As I mentioned, as transactions and blocks get forwarded by the scanner to the bot, you of course have that data, but maybe there is some external data that you need to utilize. So if I think about a flash bot detection bot, you need to query essentially the flash bot interface in order to determine whether a particular transaction was actually submitted through Flashbots. What chains should the bot run on? This is particularly important if you're hard coding particular addresses that may be different from chain to chain. Then you move into the implementation and testing. As I mentioned earlier, the implementation, the SDK supports currently Python, JavaScript, and TypeScript. And then there is a whole slew of testing opportunities. First of all, unit testing, of course. And then you can also retroactively run your bot on past transactions. This is particular a useful tool if you want to validate whether your bot identifies the kind of the type of attacks that it's intended for based on past attacks. And then you can also locally run it against a live transaction feed. And that kind of gives you a sense on whether there's any errors, as well as generally kind of the volume of alerts that your bot would emit. Once you have developed your bot, you move into the deployment stage. Again, it's permissionless. All you need is a little bit of Matic because essentially the deployment will lead to a transaction on the Polygon network to register your bot. Can happen either through command line interface or the Forta app. Once a bot is registered onto the network, it gets automatically deployed on several scan nodes. And I think currently the number of scan nodes is about 6. And what that leads to is some redundancy and increased alert reliability. A bot, of course, then starts logging data and raising alerts. And so through the Forta app or through the subscription, you're able to explore that. And then lastly, of course, you want to subscribe to the bot, and there's a variety of mechanisms, notification mechanisms that you can choose from: Telegram, Slack, Discord, webhook, and then there's also a GraphQL API that kind of allows you to explore the alerts in a pull fashion. And so now you have identified the risks, you have developed your detection bots or subscribed to existing detection bots. And as the last stage, you really need to think about the response process, the incident response process. And that will take some proactive work on your side. You need to be prepared and ready. That includes things like training. Are all the incident responders familiar with how the incident response process works? What are the communication channels? Forensic readiness. Are you logging the data that allows you to assess an incident? What is the incident response roster? Like who do you need to call depending on kind of their expertise? Are there on-chain response capabilities? I think there was a recent attack just a couple of weeks ago. The name escapes me, but funds were being drained and over a long period of time, but the protocol was aware, but there was no pause functionality. So they could just really sit there and watch. And then lastly, partner roster. So if your protocol depends on external libraries, contracts, maybe there is some aspects there where you need to coordinate, and having a roster there will just give you a speed advantage when an incident response happens. Then you will need to think about triage and declaration. So as, let's say, a FORDA alert gets raised, that itself is merely an event. It's not an incident yet. So you need to have essentially a triage mechanism where you consume the alerts, assess the alerts, determine is it an incident or not, what is the severity, and then once you identify that it is an incident, actually formally declare an incident. And at that point, it makes sense to designate one incident response lead to lead that incident. The FORDA Foundation is utilizing the FEMA incident response framework, which translates very well into the cybersecurity space and leads to better communication and a more efficient execution of the incident response. You have created an incident. Now you need to establish the channel. You need to identify the initial set of incident responders, articulate the objective, and then develop an action plan and execute on that and iterate. And then at a certain point in time, you will need to declare the incident resolve. And then after all the dust settles, you really go into the post-mortem stage to determine what you have learned, what went well, what could be improved, and then kind of develop an action plan around those, just similar to how you did with the incident itself, because often kind of these things kind of fall lower on the priority list, but these sort of action plans help to make sure that these items are getting addressed. And so that is all what I had today. Thanks all for listening. And if you have monitoring needs, I would recommend that you check out the FORDA network on app.forda.network.